Yeah, well, one of the questions really ties right into one of the points that I wanted to make. So it's from looks like Jason Campbell. It says anyone researching the Enochian Gates portals found a bunch of pictures that can overlap and seem to show a type of progression for the travels of the sun and moon. And you know, we had Zen Garcia on a while back, who's sort of a proponent for this Enochian sort of system, although I believe his model is still circular. There's a new sort of model, I guess you could say, being kicked around where essentially the Mercator projection is correct. It's a square-shaped flat Earth where you, let's say you travel west towards the international date line. Once you hit that international date line, you are essentially teleported to the opposite side of the Mercator projection, and that's how circumnavigation is done, is through not going around in any sort of circle, but actually teleporting from one side of the Earth to the other, which does sort of seem to align with the Enochian Gates. But there's been sort of, well, the other show that I did for a while, This Week in Flat Earth, there's been sort of a kerfluffle involving the hosts of that show. I don't know if you guys know Kristen Wolf, but essentially she had been sort of trying to work out this sort of flat linear model, like this Mercator linear model, for a while. And from what I gather, Lori and Lawrence have sort of taken that quote-unquote model and ran with it. One thing that I wanted to ask you guys, not so much in terms of what are your opinions of this linear teleportation model. People call it the Pac-Man model, but that's sort of an insult, so I don't use that. But what are your guys' thoughts in terms of not so much as it being legitimate, but in terms of the circular path of the sun? I've seen pretty good evidence for that all over the place. For example, the northern summer solstice. But what are your guys' preliminary thoughts on that?
Well, what's interesting about that, Bob, if you could you bring up, do you have Google Earth set up where you could bring that up real quick? I'll just show one thing. So I don't put anything past being truth, because if I can investigate it and see that it's true. But I do think that the creator would have made the world in a way that would have been evident that it was created. And I think that's already a given. But things like the sun and the moon are amazing. They should astound us. We don't understand them because we understand everything that goes up comes down. But when you're looking at the moon and the sun, they don't really make a lot of sense. Of course, they've explained it away with gravity, the same thing that your pen falls to the ground, right? Holds the sun up there, I guess. But so I look at those things and say, maybe we're not even supposed to know what they are. And that's the incredible thing. That's what tells you you're special. Somebody put that there for you. And so that's kind of the way I look at it now. So when you talk about, the Pac-Man map, well, if somebody created the game of Pac-Man and Pac-Man became self-aware inside that game, he would never be able to understand what happens when he goes out one screen and comes out the other side. In fact, if he were to try and measure that, he would probably come to the conclusion that he was on a ball because he was going around. But then if he tried to measure it, he would measure it as flat because there would be no curvature. So that opens that up to me to think, okay, that's a possibility. Now, Bob, if you grab the measuring stick up there, it's the one to the right of the little planet.
Okay, hang on a second. The one to the right of the little planet. That one. Yeah, that okay. Thing.
So if you grab that and then hit, I'll show you something crazy, which almost leads to this really interestingly. If you hit the second one that says path, the second tab, and then hit show elevation profile. Yep. Okay, now start a line at, say, San Francisco area. But in the water. Just start in the ocean. Yeah, there. Now click it, and then kind of go towards Hawaii.
Whoopsie. Oh, crap.
That's
Sorry.
okay. You could just keep going. It should let you keep drawing the line. If you kind of go towards, just kind of start heading towards. It'll be a path. So you can just keep clicking it. Like, it'll keep drawing a path. Like if you just go out towards the water more, see how it'll keep letting you click it?
Okay.
Then now go out towards Hawaii and click it again.
Yeah, you went the wrong way the first and second time.
Okay. Then keep going towards Hawaii, like zoom out a little bit. It stays with you because it's drawing a path. So zoom out so you can get more towards Hawaii. Ouch.
Oh, crap. Yeah, the problem here. Let me clear it. Let me start again.
Okay.
My bad. All right, so let's try this again. All right, so let's start here.
Yep.
Roughly?
Yeah,
Okay.
sure. And then go like halfway to Hawaii and click it again. That's fine that it does that. And then just keep going towards Hawaii a little bit more. It's weird that it's doing that zoom in already, but you should be able to keep doing it.
I don't know why it's doing that. Let's just go back again. I think I know why it's happening. So let's go here.
Click.
And then here. It still wants to zoom. I don't know why it's doing that.
But you
Yeah,
should be able to
just
pull
scroll
out.
low. Yeah, scroll
Yeah,
over.
I can go back out.
There you go.
and
Now
then
just
click
keep
on
going.
Hawaii.
Okay, now go down to Hawaii.
Sure. Because we actually need to go further. We're going to go past the anti-meridian. So go again. Further out towards the left. Go more towards like you're going to Japan.
Okay.
More. Okay, now spin around. I think is that past the anti-meridian yet? Keep spinning or spin the globe. You should be able to grab that right there and pull the globe to your right. It'll still let you do it. Yeah. And then just click again. I think we went past it. So if you take your mouse and go down there in those red lines, and if you kind of move through, it'll tell you the sea level throughout the whole thing, right? And let me see, zoom in. Now, sorry, I hate to tell you to do this. Just zoom into that yellow line, get real close to the end of it there. Real close, like, yeah, right about there. Yeah, there you go, get real close. Okay, so now we can start tracking that and how far the level is, right? So, and it will move you automatically when you move down below at those red lines. So you'll notice, see how it keeps your sea level going the whole time. At the anti-meridian, every time you go, it will. Let me see.
Yeah, I can present you. Why don't you put it on yours? Because obviously I'm having problems here.
I'm so sad that I'm a pro at Google Earth. It tells you how often I spend stupid time here.
Yeah, I don't spend much time with it.
We are the Globebusters, not the Globe Strokers. So just saying.
Let me see. Just go to the entire screen. Share. Am I sharing?
I don't see you yet. There we go. And present to everyone. Now you got it.
Okay. So I'm just going to grab here, and I've got the line drawn on the anti-meridian here, so I can kind of see. I'm going to go past it. Go here. Oops. Oops, I'm not on path. My bad. There we go. Hello. Okay.
It's like Mrs. drying her hair again.
That's my computer saying, don't do all that.
Well, your audio hasn't started breaking up yet, so that's a good thing.
So now I've kind of drawn these back and forth lines going across the anti-meridian, right? And as I start going through here, like if we zoom into here, and is that this side or the other side? Oh, so we'll start up here. And as we go through, you'll see that there's some, at the anti-meridian line, there's like a, where is it? Hold on. Is this one right here? Okay. I did see it a second ago. Now I don't see him. Where'd they go? Let me clear and see what happened here. So usually when you go across this line, I think I showed you this one time, Bob, before, didn't I? Okay, there it is.
You did, yeah.
You know, this is level. This is sea level. So it's calling that 0. And then right when you get to the anti-meridian line, there is a drop to negative 16,000 feet. It's 3 miles. But then as soon as you get to the other side of the anti-meridian line, you're back up at 0 feet. So again, it's Google Earth, so it's not necessarily facts, but I've never heard of anything that would cause any kind of a drop like that. And if you notice, if you start going back and forth with these lines, every time you cross the anti-meridian, there's a 3 mile drop. Now that's something, I mean, nobody's going to ever say that they've seen that in the ocean, but maybe there's some sort of, so when John was saying that, somebody believes something happens at the anti-meridian line, and this is the date line, right? So imagine also, how did they ever come up with the date line? How is there, who came up with that? It's not a...
Right. I mean, I always thought it was just an arbitrary thing, but apparently there's people that claim that there's bizarre things going on there, like sort of at the Bermuda Triangle, where you'll cross over that international date line, and it appears as if like you're in the wrong day all of a sudden.
Right, and I've heard people say things like that, and again, you just keep drawing this line back and forth, and again, and this should tell you the Earth's not a ball, because right here we're going from 0 feet to 0 feet. There's no change, and that's a big distance there. You can go even crazier, go, you know, what's this? This is probably, it's probably 2,000 miles from Hawaii to San Francisco. It's a guess. So if we go here, right. Yeah, so now, I mean, that right there.
Now sorry, go ahead.
I was just saying there's no change in the, it's just calling that 0 feet until you cross the anti-meridian line. Now when you cross that, again, if you start here and cross it, you're going to, coming over this way. Now why is that doing that there? Now I don't know what that's doing. But what's this line? Oh, so here's where it's dropping here. So right when it crosses that line, it's really weird. And it doesn't do that in south over Antarctica. It actually makes sense here if you go across from here to here. You're going to see exactly what you would expect, which is starting here. We're at 0 feet. Now, right when we get to the base of the hill here, it's going to start to go up. 194. Now you're at a mile high, which is right in here. Now you get all the way to the highest, which is almost 2.5 miles. That's right as you go over the center, and then you go back down, and then you get right to here, and you're back at 0. So it makes sense there. Everything, you know, kind of coincides with what we would think. Up here at the North Pole, though, it doesn't quite do what you think it would do, because if you take this line and go right here, so this is weird because now we're here at 2 miles below sea level. And as we go up to the North Pole, we kind of never make it back to sea level. It just doesn't make a lot of sense. It's confusing, but at the same time, I always ask myself, why do they show these things? Why is the anti-meridian a drop-off? Why is the North Pole a hole?
Well,
you get here.
You know, the reason why I think there's all these discrepancies is because the Earth is actually flat, and they're having to skew data around in order to make the numbers work on a globe. And so I would definitely expect to see all sorts of strange anomalies on the globe, but isn't it convenient that this major anomaly in terms of the international date line is way out in the middle of nowhere where nobody's really ever going to go? And so I think, like, you know, things like the Bermuda Triangle and things like the international date line, I mean, I've never left America, so all I have is second and third hand knowledge, but I've just seen so much evidence for a circular system with the North Pole, magnetic north in the center, and the North Star in the center, and everything else sort of being situated relatively around that. Now, I know that there are issues with taking lights in the sky and trying to ascribe relative distances based on that, because of issues that we've even discussed in this very video here. But at the same time, I think that further study is definitely warranted. But one thing that I suggested to Kristen, who, by the way, was telling me, you know, details about this model and sort of bouncing things off of me weeks before Lawrence and Lori sort of touted it as their model, so just saying on that. But one thing that I suggested to her, and I don't know if you guys ever remember hearing about this experiment, but I talked to a couple different people on some social media who, one of the guys was a globe earther trying to debunk flat Earth, and what he did was he got in his SUV with a very good, you know, built-in compass, and he put himself in a very wide open area where he could drive unimpeded for many, many miles, and aligned his direction so that a city in the far, far distance was directly west. And what he did was he kept his alignment with that city due west and went perfectly straight for it, I believe for like 10 miles or so. And what happened is the compass actually drifted to where, even though he went perfectly straight towards that city that was due west of him, the compass drifted so that he was facing slightly west-southwest,
I
which
guarantee that happens, yeah.
yeah, which would be perfectly in line with a circular flat Earth where the latitude lines are curved. And so now I've never done this experiment, but I heard lots of people talking about it. And in fact, one of the guys was a globe earther who was going to debunk all of this because of that. It was just totally astonished. But I'm just curious as to whether you guys had either spoken with anybody or even done that same sort of test with a.
You should, because there's definitely, if you just look at this from Hawaii here to Mexico here, and it makes you draw that curve. See that curve? Which
Right.
is ridiculous, because why can't I just go the path and then go this way?
Yeah, that curve should follow the latitude lines because
Right.
the latitude lines are assumed as a curve.
Right, so I could go this way to get to that same place, and we know that the straightest distance between 2 points is a straight line.
Exactly.
So I should be able to get here, right?
Yep.
But yeah, I have to go here. And I've showed this before. If you take just a line and you go Hawaii to this part of Mexico,
Yep.
okay, so we're looking there, it says 3,600, 3,598. So if I start moving my mouse up this way, this is a farther journey, right? We're at 3,600. But
Yep.
if we do that, watch what happens. So if I go here, so we were 3,600 here. Now I'm going to start moving my mouse up, and you'll notice that we're at 35. We're at 35. Hello, I'm moving further away. 35, 35, 35, 35. Here we're at 36, but I can kind of cut back here, still at 35, 35, 90, 35, 90, 37.
Yeah.
35. This means that this distance is the same as what I was just at in Mexico? There's no way. I'm all the way up in Canada. Look at Canada, I'm still at 36, 35, 92.
Now,
That's ridiculous. That is not the same distances from here to here. It's
That's-
high.
totally true. Now, your audio is breaking up a little bit, but could you do me a minor favor and draw that arc from the southern tip of South America to New Zealand?
Which way?
Go west. There you go. Okay, so you'll notice how that's a curved line. Okay, but what you did before was you created basically a chord of that arc, which was a straight line between those 2 points. Now, during ancient times, when people like Magellan were circumnavigating the globe, they were naturally following these curved paths because it was all done by observations of the stars. So they sort of had to follow along those curved paths with the stars. Now, here's my point. With modern navigation, we have the ability to follow that chord of the arc as opposed to following that arc, which is, a thing with manual nautical navigation. It sort of has to be an arc because you're using the stars as guidance. But with modern technologies, we're able to shave off a great deal of distance, which, by the way, even according to, zetetic astronomy, which I'm not going to use that as a source, but even according to the very, very old model that Robotham was describing, that distance is totally doable with a commercial airliner within 12 to 14 hours. Totally doable, especially when you consider modern jetliners are not necessarily following those, manual navigation arcs. I guarantee you they have the ability to sort of cut that corner and follow the chord of the arc. So I think that's a point that really needs to be driven home, because people like Tiger Dan and a bunch of ignorant globe earthers are supposedly debunking the flat earth because of that flight from Chile to Argentina, when in fact it's totally doable in a flat earth model.
It doesn't need to do a big arc.
Yeah, Exactly. And of course, those distances in an azimuthal equidistant projection, they're all skewed and far more disparate than they actually are anyways. So it's just a projection. I mean, you can't go by that and say, oh, well, that's way too far to fly in 14 hours, because it's not. I mean, it's totally doable. So anyway.
People don't know how fast those planes are going.
Yeah, but I average probably 550, and even then it's still doable.
But I'm saying even if they wanted to go 650, who's going to notice?
Right. Well, you know, another thing I thought of.
Hello, everybody. We're back. This is Lori and Lawrence, and we're back for our second week of our new show called Free Our Flat Earth. And we have some things to talk about this week that are in addition to and on top of what we've been talking about for weeks and weeks, and that is that the azimuthal equidistant map that the flat earthers call the flat earth map is incorrect. And we've been approaching this from just a sort of an attack mode for several weeks. Attack mode meaning that we've been getting kind of like angry at people who keep pretending that this map is still the map and that it works, because it doesn't work. And one of the things that we're going to talk about today is Lawrence has gotten a map, and he's been plotting on the map different routes and cities and things, and we'll see if what he's come up with. And we're just sort of going to get right into that, and then we're going to talk about all different kinds of topics as we go. So welcome, and thank you for joining us again. And I'm going to give it over to Lawrence and see what he's come up with.
Okay, well, I don't know whether you can see behind me. I ordered this large blown-up version of the sinusoidal map, which is kind of like a diamond shape, where it's the widest at the equator, and it tapers into a point at both the poles. And what I've done, I've plotted over 20 routes, looking at the official flight information out there, saying how far it is. And this map is to an approximate scale of 1 centimetre is 300 miles. And I've done the 21 routes. If you can bring up the small version of it on the screen, Laurie, I can go through the different routes with people, and then they can see how accurate or otherwise it is. But it's pretty accurate. If you can bring that little...
Okay, are you talking about the one with the equators, or the one with the route map?
We'll do the routes first, and then we can talk about the distances across the second.
Okay, share screen.
Share screen.
This one. Share. Present.
Okay, you can use your pointer there. Have you got your pointer there, Laurie? Can you put your pointer on?
Yeah, but I don't think it shows up on the screen. I asked last week, and people said no, that you couldn't see.
Just try moving your pointer over it and see whether it comes up.
Okay, well, I don't know. You have to tell me if you see my cursor.
All right, I can see mine, but I can't see yours.
Okay.
All right, so let's. So what we've got here, to verify that the continents are correctly aligned with each other, you know, in terms of their position, the best way to do it is to form triangles between places that are a great distance apart, and see how the numbers stack up.
All right, I'm told that the cursor is showing up on the screen, so tell me where to find it.
I can't see it. Move your cursor over Winnipeg. You know where Winnipeg, right in the middle of Canada?
Yeah, right here.
Yeah, okay. Well, Winnipeg's right in the middle of Canada. So if you look at Winnipeg,
that's the top triangle. For those
the yellow one,
who may not be able to see it, I'm not sure whether it's showing up or not, but there it is.
Well, Winnipeg's the middle of Canada, so people know where America is and Canada. So you got Winnipeg, okay, and if you go across from Winnipeg on the diagonal line going down, that's going down to Giza. Winnipeg to Giza, the official flight distance is 6,089 miles. On the map, it's 6,150, so almost spot on. And then you go back to Winnipeg and you go all the way down to Santiago, and the official distance is 5,962, and on the map it's coming out at 5,850. And then completing the triangle, taking Santiago over to Giza. The official distance is 7,950, and it's coming out at, oh, you got it now, yeah. It's coming out at 7,650. So that is a pretty accurate triangle there. So let's try another one.
Okay.
So if we take New York, so put the pointer on New York. You got New York. Yeah. Over to Giza. The distance is, official distance is 5,618. And on, by the way, for the map, I've used this steel rule. Okay, so I measured out the distances on here. So every centimetre is 300 miles. So we've got New York to Giza, and that's 5,618. On the map, it's 5,7. I've got these in a certain order. We'll come back to the rest of that triangle. If you move down to Orlando, Laurie.
Over here.
Orlando to Nairobi. Now Nairobi's on the equator in Africa. Okay, Orlando to Nairobi. Official distance 7,966. On the map, it's 8,100. Orlando to Cape Town. So Cape Town on the tip of Africa. Yeah, the official distance is 7,804. On the map, it's 7,650. Again, pretty accurate. Back up to Winnipeg, middle of Canada. Yeah, Winnipeg down to Santiago. Official distance 5,962, and on the map it's 5,850. Back up to New York. Now we go New York down to Santiago, Chile. Official distance is 5,107 miles, and on the map it's 5,100. Santiago over to Cape Town, so you're going across. Official distance 4,945. On the map it's 5,100, so 150 miles out. Then Santiago up to Giza, so that's the yellow line going up to the, where the pyramids are. Official distance is 7,950. On the map it's 7,650, so 300 miles out, still pretty accurate. Santiago up to London, if you can still see what's left of London up there. That's going up that one. Yeah, official distance is 7,239. On the map it's 7,200, so 39 miles out. Santiago up to Nuuk, which is towards the tip of Greenland. Official distance is 6,804. On the map it's 7,350. So it's about 500 miles out. It does get a little skewed once you get above the 50-degree mark, but it's still pretty accurate. The next one, Cape Town to Giza, so back over to the tip of Africa, up to Giza, 4,476. And the official distance, the actual distance on the map is 4,500, so 20-odd miles out. Cape Town to London, 5,987. Official distance on the map it's 6,000, so like 13 miles out. Cape Town to Tokyo, so you've got Cape Town, Tokyo. Yep, you've got that one. Good geography there, Laurie. 9,156 the official. On the map it's 8,550, so it's about 500 miles out, but in the scheme of things it's still pretty accurate. Cape Town to Nairobi, so that's halfway up Africa. Yeah, up to there. The official distance 2,541. On the map it's 27, about 150 miles out. Cape Town to Sydney, so that's right across the bottom on the red line. 6,856 is the official distance, and on the map it's 7,500, so it's about 650 miles out, but still pretty accurate. Sydney to Tokyo, so that's going up on the yellow line. That's it. And then up to Tokyo, Official distance 4842. On the map it's 48, so 40 miles out. Sydney to London. So you've got Sydney all the way up to London. Official distance 10,558. On the map it's 10,500, so that's remarkably accurate over such a long trip. Nuuk to London, so that's the little jump over to Greenland. Official distance 2,025, and on the map it's 1950, so like 75 miles out. Sydney to Johannesburg. Now, Johannesburg is that yellow line that goes at a slight angle up into the other side of Africa at the base. So Sydney to Johannesburg, 6871 is the official distance. On the map it's 6,900 miles, so it's about 30 miles out. Tokyo to Giza, so you're going to Tokyo and then down to Giza. Official distance is 5961. On the map it's 6,000. And Sydney to Santiago, this is a bit out, but not much out. If you go, this is the black line, so you're having to fly off the map and up the other side. It's coming out at 7063 is the official distance, and on the map it's 7,500. But if the black line went down slightly, instead of going at, horizontally across, if it went down slightly and then came up, it would actually constitute a little bit of a shortcut, and it would fit with the correct mileage. But even doing it in a straight line, it's only 400 miles out of 7,000. So all those places, they all triangulate well, and the distances are all within 5%. The worst anything is 8 or 9% out. So that is a pretty accurate representation of where the continents are to each other, the size of the continents, and the route side up. Once you get quite high up, if you bring the other drawing, Laurie, which is showing you the actual width across the Earth from one side to the other, you can actually see how skewed the Mercator map will be, because obviously that's a square map all the way. So if you can try and bring that one up, we can cover the distances on that. Okay, so for the equator, that's the big red line across the middle. If you want to put your cursor on the middle one, Laurie, so people can see the equator. Yeah, that's the equator. Okay, so using flight routes on the equator. Okay, I'm looking at my map here. Across the equator, we've got Quito, which is on the east side of North America. Sorry, South America. Quito, it's just on the left. If you go from Quito to Nairobi, so Nairobi is, on the east side of Africa. That distance is 7,976 miles. And then you do Nairobi to Singapore. So if you can find Singapore, which is about there, yeah. Nairobi to Singapore is 4636. And then Singapore, which goes right to the very east and then back over the other side, back to Quito, that's 12,268 miles. Near as damn it, it's 25,000 miles. The exact figure on that is 24,880. Okay, and then I've got flights from all the other routes going up. If people want to know them, I can give them. But if you look at the next line up, the next yellow line up going north, which is at the Tropic of Cancer, the distance across there is 20,352 miles. And we've got, and that's based on Havana to Jabalpur. Jabalpur's across the Indian continent. Jabalpur over to Shantou, which is in China, a bit further over to the right. And then Shantou all the way back to Havana. Total distance across is 20,352. If you move up to the next line, which is 50 degrees, so the one that goes through the base of UK. Yeah, you've got that one. Okay, the total distance across there is around about 14,000 miles. And on that, we've got Winnipeg to Paris. These are all roughly on the same latitude, 50 degrees north. That's 4,130 miles. Then you've got Paris to Sakhalin. Now, Sakhalin is just off the edge of the Soviet Union on the corner. That's about right, yeah, to Sakhalin, which is 5,001 miles. And then Sakhalin across the map off the edge and back over to Winnipeg is 4,591 miles, which near as damn it adds up to 14,000 miles. If you move up another 10 degrees to latitude 60 north, the distance is 9,649 miles, so it's starting to shorten up quite rapidly. And on this one, I've got Anchorage, which is Alaska, you know, on the not far off the tip of there, and there we're going over from Anchorage to St. Petersburg. St. Petersburg is just past the UK. No, not that far. A bit more to the left. Round about a bit more to the left. Yeah, to St. Petersburg, which is where are we? 4,084 miles, and then we got St. Petersburg to a place called Magadan, which is right on the edge of the Soviet bloc. And that distance is 3,600 miles, and then Magadan back to Anchorage, so it's going off the map and back onto the other side, is 1,965 miles, which gives you your 9,649. Now, if you move up the latitudes further to, now I haven't got any flights on this because there aren't any to go off, so I've used what's known as, there's a little app on, or a little program on the internet, and it's, if you just Google calculate the distances between various latitudes, you can work out the distance. So you work out half the distance. You can't work out all of it. It'll only do half, because if you do more of it, it finds the shorter route. So if you do 50% and double it, that will give you the distance. So at latitude 70 degrees, so that's up to the next line, which is the one above Nuke. No, that's the top line. Down one. Go down one. That's your 70-degree line. And at that distance, that latitude, the distance across is 5,527. And you go up to 80 degrees north, which is the top red line. And the distance across there is 2,764 miles. 85, which I've not got marked on because it's too tiny. At 85 degrees north, the distance across is 1,382. And if you go to as far as the top as you can, 89.5, just before the very top, it's less than 50 miles across. It's 46 miles across. So it looks like both the poles go to a single point, you know, and form some kind of a diamond shape. So that tells us that what Robotham is saying, because these distances are exactly the same when you look at the flights going across the bottom. So if you look at the one on the bottom line, which is, where we go, 50 degrees south. So we've got a place called Stanley. Now Stanley's just on the tip of South America.
Lawrence, you need to try to face the mic better to talk, because it's coming out a little babbled, I think.
All right, well, put your cursor over Stanley. Stanley's just a little island off the tip of the South America to the left of where you are. That's Stanley. So from Stanley to a place called Kerguelen, which is, if you stay on the same line of latitude and move down from Madagascar and a little bit to the right, yeah, now down, more the other way, a bit more to the left, a bit more. Keep going.
Very well.
All right, stop there. That Kerguelen's about there. Oh, Kerguelen's like a research base. So from there to there, the distance is 4,779 miles. And then from Kerguelen, the furthest place south I could find is a place called Stewart Island, which is just off the tip of New Zealand, so which is virtually on the edge. And that distance is 4,213 miles. And then from Stewart Island, which is going off the map and back across the other side to Stanley again, it's 5,049 miles. So at 50 degrees south, it's the same as 50 degrees north. It's 14,000 miles across. Now, Robotham will have you thinking that it's more than 25,000 miles across. You know, he'll be telling you it's 26,000 miles across. Well, it isn't. You know, the poles, you know, as you approach the poles, they both taper into a single point. And that's giving you the four corners of the Earth. You've got the east, the west, the north, and the south. Those are the actual 4 points. And I've done some more work on the equal lengths of day and night. So I know we talked about 1 last time, but I've got 4 for you now, all at different latitudes, the same, north and south. So we've got Cairo. So Cairo is up by the pyramids. That's latitude 30 degrees north. The comparison is 30 degrees south. And the longest day in Cairo, which is in our summer, is 14 hours, 4 minutes, 56 seconds. And Port Allegra is 14 hours, 5 minutes, 3 seconds. So there's 7 seconds difference. So that's at 30 degrees north. If you move to 41 degrees north, you've got Uzbekistan. Longest day, 15 hours, 9 minutes, 45. And then Nelson, New Zealand, 41 degrees, 16 south. The longest day is 15 hours, 9 minutes, 35 seconds. So 10 seconds difference. And you've got Swansea in the UK. Longest day, 16 hours, 39 minutes, 40 seconds. Rio Gallegos, which is the tip of South America, 51:38 south. Their longest day is 16:39:54, so there's 14 seconds difference. And the last one, we've got Flensburg, which is in Germany somewhere. That's 54 degrees 47 north. Longest day 17 hours 19 minutes 24 seconds. And Ushuaia, which is in the south, 54:48, so they're more or less identical in the south. Longest day 17 hours 19 minutes 53 seconds. So there's a difference of 29 seconds on their longest day. So there is perfect symmetry, because these places are not absolutely identical, but within a few miles of each other. The symmetry is perfect for north and south, and that just does not work on the AE map.
Okay.
Wow. The stats, folks. Sorry to bore you with all that, but the map is working out pretty spot on. It's not 100% accurate, but it's the best we're going to get so far, short of drawing one yourself. I've looked at lots of other maps that are similar. You know, there's hundreds of maps out there if you start looking for them. But that's the best you're going to get from all the information that I've looked at. And short of drawing one yourself and plotting all the airports, you're going to be hard-pressed to find anything more accurate, and it's not going to look too dissimilar to the one we've just presented to you.
If you haven't been to timeanddate.com, it is an absolute must. You go to timeanddate.com, and I think I put that link up here today somewhere. Let me see what I put in my little notepad. No, I didn't. Okay, so you go to timeanddate.com and you click on, there's a you know, they have the top line of menus, and then there's a sub menu line under that, and you go to sun, what is it? Sun map, yeah, map the sun, and you click on that, and it takes you to the active sun map of where you are. It knows where you are. That's always incredible to me still to this day, that everybody knows where you are when you're signing into a website. And it says, you know, it shows you where the sun is, and then it shows you where the light from the sun is, the sunlight. And then it fades out a little bit to the twilight areas and then to the dark areas. So it was interesting that it was dark where I was, and it was dark in South Africa, but light in the middle. And because you can't really see an eclipse in the daytime very well. So that also was another phenomenon that kind of made me go, wow, how does that work? But then I had
It's the
realized
sine
I'm
wave,
looking
isn't
at
it?
a flat map. I was looking at a Mercator type map because that's the map they use for timeanddate.com, right?
Yeah.
I mean, that's where you got started looking at the whole phenomenon of the time and date on the northern and southern hemisphere thing. Was
You can
on
still have the
time
sine wave on the sinusoidal map. It would still work. It would probably
Yeah.
work better because you've got the V at the bottom.
right.
I mean, free energy says that it's you know, the sine waves caused from the sun coming off the foundations of heaven. That's what he puts on his videos. But there obviously is something, because obviously you can have sunlight, darkness, and sunlight in two places, because this, you know, the way this big curved thing goes.
Right.
So there must be some other effect other than the sun itself. It's not, the sun isn't making a
Yeah, it's not making a little, yeah, like on the AE models, they always show, you know, the
not
sun's
like the
going
A
around,
model, no.
the sun's going around a little circle. You know, we've
Yeah.
seen it 1,000 times, and it's got a little circle of sunlight around it, and it just goes around. And
Yeah.
you know, that was one of the first things that I saw that debunked that was comparing timeanddate.com, the length of day over here to where that circle of sun should be over here, and it didn't make it. It didn't work because the sun doesn't make a circle of light. It makes like a sine wave, a big fat square sine wave. So so at the end of the day, when you start to take these things apart, your mind wants to refill that information, wants to replace that information with something else. And, you know, it's like if a person is crazy and they think they're a duck, I mean, they really, really, truly believe they're a duck. They look in the mirror and they see a duck looking back. If you try to convince that person they're not a duck, they're not going to understand that until you tell them what they are instead. Okay? Because they can't just be, if they're not a duck, they can't be nothing. They have to be something else. So you have to describe to them that they're a human, and you have to make them understand it. Well, that's kind of the same phenomenon, you know, you go through with becoming a flat earther. You have to let go of your entire lifetime's belief system of the globe and everything associated with it. And then you have to be able to go back and replace that information with something else. And you have very little to go on when you first start, because you don't have enough information. You know, you have to start throwing away ideas like gravity, for example. You know, like today, I saw a cute little video, and sadly, I would love to share this video, but I can't, because the guy that made the video put a super loud music over the top of the dialogue, and you halfway can't understand what he's talking about. But it was about bumblebees, and he said when he was in school, when he was a kid, his teacher told him bumblebees can't fly, but the teacher never told him why or what they are doing, because they're obviously flying. Okay, but the teacher told the guy, you know, bumblebees can't fly, and aerodynamically they're defying physics, because, you know, and I'm talking about bumblebees, the big ones that are like they like look very cumbersome when they're flying. Same way with June bugs or beetles, the same thing. They just sort of bang into stuff all the time and hit the wall and fall down and start up again, and it's pretty laughable, actually. And so so the guy later on tried to figure out, okay, what is he talking about? And he came across the information that it explains that bumblebees aren't actually flying, they're levitating. And so same way with large beetles, you know, that have a pretty big body and their wings aren't that big. You know, they have those, I don't know, little hard wings, and then they open those up, and then there's some like little wings underneath it there that actually make them fly. And he described about that the bumblebee is actually getting to the same hertz, I guess through sound, to the same hertz as the surrounding world, and that allows it to actually levitate. And so when I first saw this, I was like, I don't believe in levitation like that. But then I started understanding what he was talking about, because he went into some other information about how the wings work with magnets and, you know, all kinds of stuff. You'd have to see the video, but look it up. It's something like bumblebees can't fly. And it was like all new information to me that made sense then, because we used to laugh when I was a kid in the country at the June bugs that would come out in June, and they were those big blue-green beetle bugs. And then when they would fly around, they were constant. And there was brown ones too. They were constantly running into the wall and running into you and banging into everything. And you know, it was like one of those hoverboards got away from you or something and just shot you out over there somewhere. And so that's you know, sorry, I get anecdotal little stories sometimes, and I apologize. So you can just fast forward past them anytime you want. But I always bring it back. The idea is that when you learn something new, you have to it has to take the place of something old that you understood, or you thought you understood, or you thought you knew, because you actually didn't know anything. You just believed something, and that's how the flat Earth information starts coming into your head. But once again, I have to reiterate, it's lazy to just listen to what someone else says and not verify it and not check it, because they could say something very smooth and savvy and sound like confident and sound like they know what they're talking about, and they're telling you a bold-faced lie. But maybe they believe it. It doesn't matter what their intention is, whether they believe it or not. So so how do you feel now about how, after you have done this triangulation on this map, where do we go from here, Lawrence?
Well, short of actually getting a load of technical drawing equipment and using that as a starting point, that's about as far as I can take it, you know. But the figures I've given you today prove that those layouts are as good as it's going to get.
Okay, so then now we have to one more time. It's feeding back. So now we have to deal with the one issue that makes this work or not, and that is the idea of how do we seamlessly go from east to west at the end of this sinusoidal map.
Well, that raises another issue, because every flat earther will tell you that there are no satellites, because there isn't a planet to orbit. But if you've got portals, then the same way as an aircraft can go seamlessly from east to west, then low Earth orbit satellites could do the same. So there is this International Space Station, which is probably some tin can that's flying around, but that could technically orbit the flat Earth if it's actually passing through the portals on one side and re-emerging on the other. It's probably an area to look at to see what the flight path is, or where the International Space Station, this tin can, wherever it is, where it's observable, because that may well prove the portals. Because you know, what countries is it seen? You know, you can see it in the UK, but can you see it up in Sweden or up in, you know, South America and places like that? Where is it observable? And it may well be that it's, you know, it's going from east to west and it's passing through the portals. So that could be another area of investigation. People could start plotting where it's visible on the map, and then try and figure out, you know, which way it's going.
Well, it looks to me like it makes a sine wave pattern, and
yeah.
The same as the sun and the same as the moon. if the sun and the moon are traveling a straight line, we'll have to deal with this issue of how do they seamlessly move from east to west. I mean, it's interesting because it's kind of, I thought of it immediately as one of those, ooh, you guys did that hide in plain sight thing, didn't you? With the timeanddate.com, where let me see if I can open that up, because it's bugging me that I'm talking about something that I'm not able to show. So let me go here and do timeanddate.com.
Well, somebody, I would imagine in the next 12 months, somebody is going to go and book a cruise that goes across the international date line, and the one that goes past New Zealand and then re-emerges on the west and heads up towards the west coast of America. So all it takes is somebody with a, what's it going to cost, about $3,000 for that leg of the trip, and they take their maps and compass and plot which way the ship's going. That will prove that there are portals there that take you seamlessly from one side to the other. That is a proof. All it takes is somebody with a bit of cash who's a flat earther who can, maybe they're going to take a holiday anyway. We'll take this one, fly over to New Zealand or to Australia and do the last leg of the cruise.
Okay, so here we are. Present to everyone. All right, so here we are. We're at timeanddate.com, and this is current to where I live right now. And I have to go to the other one to do the.
Well, if you look at the bottom, Laurie, if you look at the bottom where it's got jump to, you can actually move it on.
Yeah, I'm going to.
So many hours, and you'll be able to move it to such a point that you've got half the sun on one side, you've got half the sun on one edge, and half of the sun on the other, and that is depicting reality.
Okay, Can you see me on the map right now with my cursor?
Yeah, I can see your cursor. Okay. Yeah.
All right. See what the sun is. Okay, this is like the Mercator map. Okay, this is the square flat Earth map, as we call it. And you can see several things that are very interesting here that you'll make note of when you start to look at this. And most people are like, no, this doesn't work. This is a globe map. Well, they're all globe maps. Everything's a globe map, and so you got to deal with that. But you can see that Antarctica across the bottom. That's what I was talking about. That really long 14,000-mile coastline. It's pretty interesting when you look at it from this perspective. But right down here at the bottom, okay, this is now, and then I can go plus 10 minutes, and it will refresh, okay, and the sun is a little closer over here, so I probably can do 1 hour.
Well, take it the other way, Laurie, so you can show
I'm going the wrong way.
Sun on both sides at the same time.
Sorry.
Take it another 10 minutes to the right. And then another 10 minutes. And another 10 minutes, and you're going to get it half on half.
Okay.
So you can see the sun on one side, and it's re-emerging on the other.
Here's the sun over here, and here's the sun coming in over here. And this happens to be approximately where the international date line is where if you cross it, you go from one day to the next day.
That's it, yeah.
So let me add 10 more minutes, and it'll probably be a little more obvious. Oops. Okay. Move this
You
down.
want another 10 minutes?
Yeah, minus 10 minutes. Okay, now we're pretty close to the half and half. All right. Yeah. And this is pretty accurate as far as where the nighttime is. Okay. Here's the moon right now, and you have like a little bit twilight line areas around, and a little darker or lighter, and then over here it's still daylight over here in the west of the United States, and over here in Eastern Europe. So also it's daylight all the way across Antarctica. Full daylight everywhere.
So
Okay.
people have to explain how you can have darkness in the middle and light on both sides, because that wouldn't work on a globe.
No.
And it wouldn't work on the AE map. And maybe somebody should send a question to Time and Date saying, please explain how we can have this, half the sun on one side of the Earth and half on the other. You know,
Exactly.
the only way you could do that is if there are portals.
Well, I mean, this
Because
is
if you
right
plot that
here,
sun,
again, right here, you know, this is where people have to go and look on another map that, go to a map that shows the international date line, okay? This is the Bering Strait right through here where they often say they're going to build a bridge across here to connect Russia and the United States, okay? But the international date line goes smack dab through the middle of that, which is, we laughed about that when we first realized it a few weeks ago and said, there's no wonder there's no bridge there. They can't build a bridge across a portal. And so you go on down through here, it jiggy jags on and down and comes out the bottom, and that's the international date line. And it's the same thing over here. You know, that's why the sun's half and half. And the moon does the same thing when you move the moon over there. And so this is one of those things people need to just wrap their mind around. This is accurate. I posted it in Facebook today, this, you know, a map like this, and said, here's the darkness and here's the light. Only today it was the opposite. The light was all in here and the darkness was all around here. And I had people, you know, okay, here I am checking in from Australia, and yes, it was dark there. It was 3 o'clock in the morning there, and where I posted it was like 11 in the morning, and it was the opposite of this.
and the sun is not circling there, it's moving directly in a straight line. If you look at the sun on the left and on the right, you can draw a straight line between those two, because that's where it's going, in a direct straight line. The same as the moon is going in a direct straight line, and all the star trails are going in a straight line. You get these circles of the star trails. It's simply light bending. If you look at the star trail directly over the celestial equator, it's a perfectly straight line. That's the one that is straight, and everything around it bends, but it's just simply light that's bending.
Okay, right here, sorry. This is UTC time, this map right now, it's not now. This is Monday, February 29th, 2016 at 12:10 p.m. According to this, what this map will look like.
Just move the moon along, Laurie, see if you can get the moon on both sides. I haven't seen that yet. A bit for you want another 10 minutes at a time, or an hour, maybe 1 hour. Knock an hour off it.
I'm trying, it's spinning and spinning, so it's having trouble updating. I probably did it too fast.
Now you went the wrong way, you want to knock it off the other way. And then knock another hour off.
Okay,
hey, half the moon on one side and half on the other. Well, how's that possible?
There's the moon.
Yeah.
And this will be it would be interesting to be in a boat right about here.
Yeah.
And see the moon straight overhead, and
so on that you could have somebody in Australia seeing the same moon as somebody in South America. One seeing one side of it and the other one seeing the other side of it, aren't they?
Right, right. I mean, this is pretty much how it works. I mean, there's no better explanation than zipping back and forth on time and date and watching how the darkness and the light work. I don't know how they explain this to people on a globe. I guess the people just say, well, you know, that circular area right there is on the back side of the globe from where I would be, blah, blah. And so, but you can go, okay, like you can do this to...
Yeah, on the globe, though, you've got the terminator line, haven't you? Where there's no terminator line on that, you've got the squiggle.
All right, so here's okay, so this is right now. All right, so let's go and look at this one, the March equinox. This is where the sun will be, see how much higher it is and see how much higher the moon is?
Yeah.
Okay, and here's the June solstice. Now, remember where you just saw them. I mean, it's like, it's the same, it'll be the same day, only 6 months from now, right? Look how high it is. Look how low the moon is. I mean, look at even the pattern, the way it's, you know, down here. This will be in darkness, 24 hours probably. And then it'll be full daylight up here, probably
Right
for 20.
across the top, yeah.
Okay. So here's September. Now it's moving back south again.
And that is giving full daylight. The one you just did, it's giving full daylight in the northern hemisphere without circling. A straight line sun is giving full daylight.
Right.
So there must be something at the top and the bottom of the Earth that it's probably some kind of electromagnetic effect that causes that sort of distribution. Because, you know, if you got a spotlight or a torch and tried to get that sort of effect, you wouldn't get it. You'd just get a circle, wouldn't you?
Okay, so here's the same. Here's the same sun in December solstice. So now it's back south again. This is, look how far south that sun goes in the winter up north.
Yeah.
I wonder it doesn't melt this whole ice across here. So the whole idea is that this thing is correct as far as the Tropic of Capricorn and the Tropic of Cancer and the equator, where it's moving back and forth high and low. And there's that perfect sine wave I was talking about earlier, or kind of almost perfect. It's interesting how the light works that way.
Yeah, and as we proved earlier that the continents are, you know, on that map that's behind me there, we've proved that those continents, that they all triangulate pretty accurately to within about 5% of the official distance. Then the sun has to be moving in a straight line, because people can check on time and day where the sun is at a certain time. And, you know, if it's sunlight where you are and you look on time and day, it'll say, yeah, the sun's over you. You can't argue with that. You know, the circling sun is a lost cause. You can't prove a circling sun. Just not going to do it.
No. So if we can't
proved it, Laurie, that, you know,
well, I mean, I feel like we have, but, you know, now people are going, well, so now what? Okay, so you wrecked our map and you wrecked our model, and now what are we going to do?
Well, we've given them a new model. You know, they need to work on what we've got, and maybe they want to improve it. You know, maybe they want to try and put together a map of their own. There's that guy, French-sounding guy, who's talking about people having compasses in different parts of the world. I'm not too sure whether that will ever materialize, but he was talking about putting together, and he actually commented on our last presentation last week, saying we should stop slagging people off. You know, we're only slagging people off who are telling lies. And we haven't slagged anybody off this week, so nobody in person anyway.
No, and it was really, sorry, takes a second for that feedback to stop. There's no reason anymore for us to do that anymore. I mean, you know who you are. You know who you are that are, you know, see, if I had been making all these videos of circling suns and moons and circling maps, and I discovered that they don't work, I would feel compelled to remove those videos and make new ones. And there's no need for an apology. I mean, it is what it is. We all thought that. We all thought that Robotham had it all figured out, and that's where a lot of this came from. The Flat Earth Society, I read a long dissertation on the Flat Earth Society today and the history of and where these maps came from. The UN map was created when the UN was created. It's not like it's thousands of years old. It was what, 1945 or something like that. And And so why did they pick that map? I have no idea. Why are there 33 segments in it? You know, the classic 33 Masonic thing. Why? I don't know. Why is the AE map look like it, only instead of putting the United States front and center, the European Union's front and center? I don't know. But it doesn't matter why, or, you know, who did it. But if we're going to continue to use it and knowing that it doesn't work, why are we doing that? That's my big question. How are we going to get anywhere? They're all laughing at us if you know, the Illuminati or the Masons or they, them, the cabal, whoever, whatever wicked name you have for them, they're laughing at us. And they're like, oh, you know, we punked those guys pretty good because all we did was insert that map 45 years ago. And it was the New World Order map. I mean, not 45, in 1945.
They're still doing it, Laurie. I mean, there was the video out today, and I'll say here it was by Russian Vids, and he's put another video out today with the fucking AA map again. I mean, maybe you should watch our program. We spent like 4 months or longer, you know, totally destroying the everything about the AA map. Nothing about it works, and yet they're still doing it. And you've got so many people out there who are using their AA map as part of their little logo on their page, or, you know, on their little avatar for themselves. They're still, like, you took yours down after I suggested it was a good idea to have that on the page. Maybe you should change it to this map here and stick that on.
Well,
you know,
I'm probably, you know, I'm probably going to do that. You know why? Because repetition is the key. That's how they stuck this map in us, in our movement, and kept repeating and repeating, and it seems to have worked. You know, of course, on top of that circle nicely fit the dome, and so I'm not going to go there. I've been there enough times that everybody knows how I feel about the dome and the limits that they've created with this dome, and that it's not based in anything real. There's no empirical evidence of it at all, not even sundogs and all that other stuff, and rainbows and everything else. I mean, all of that's been debunked, and people have stopped pretty much talking about that now.
I know,
in my opinion.
Laurie, even when they're directly addressed with the question, I'm not even going to mention who his name was, but one of the most prominent flat earthers did a radio show, and the host asked him about the Earth being square, and he just gave a blank look. He did not answer the question. They just don't go there. The guy was embarrassed. Wasn't answered at all, you know.
Just so you know.
But these questions.
Wait. That person that asked him that, and it's okay, because, you know, we can't stop saying the name Mark Sargent, because that's who you're talking about, right? That
he was asked square.
Paul Sandu asked him. Yeah.
That was it. Yeah.
I've invited Paul to come on our show and see what he knows about the square flat Earth.
Yeah.
So he's on.
There's a few people latching on
sooner or later.
You know.
And I'm trying to get free energy on here, but he's just not ready yet to make a presentation, and I'm not going to push him. I mean, I would like to pick his brain, and so would probably a lot of other people. But interestingly enough, I've had several people this week after last week's show send me messages. One was actually on the channel here and said, I apologize. I was mad at you and Lawrence and thought you guys were crazy and wrong for going after the AE map and so on. And now I admit I was wrong, and I apologize. And no apologies are necessary. Absolutely not. But glad to know that we're getting through to a few people that, you know, we're not pushing our model. This is not our model. Sorry, my foot's itching. I don't want these squirmy.
It's not. I mean, the main point is to show that the model that's being presented by 95% of prominent flat earthers is an incorrect model, and if they ever get in front of primetime TV and present that to them, then if we can pull holes in it, then they'll find the faults with it as well, and there'll be a laughing stock.
Yeah, they're gonna be in big trouble. So, you know, it's not my responsibility, it's not your responsibility, but it is the responsibility of anybody who calls himself a truth seeker and a flat earth researcher to actually do the research and to actually, you know, find the information. And if you find something didn't you believed before, now you don't, and it doesn't work out, then stop saying it. Maybe it'll just, you know, go away into the, you know, trash bin somewhere over time. But so many people, you know, they've built their channels with this information. They've built their you know, subscribers up, the list of subscribers up, and they've built their you know, view count up with this information. Who can put out the most videos the fastest, and who can get the most view count. I'm not concerned about view count, and I'm not concerned about subscribers. I appreciate subscribers, and I think it's the best way. We only do a weekly show. I'm not putting out, you know, 10 videos a week on this channel like some of the other people are. So you're not going to get bombed with notifications for subscriptions. But at the same time, the you know, if I'm going to go back and look at some of mine, and I know there's a couple of things a couple of videos that I've put up, you know, a year ago, almost maybe, that are wrong now, but they're hangouts and we were talking about it. So I'm not really sure that counts because we're still talking about it. But you know, I've started removing information from the Facebook groups and pages that is wrong, because the one about the 2 mile high ice wall all around the outside. Let's go back there for a second, okay?
Well,
the part about the military of all these countries will blow you out of the water if you try to go there. Okay, I believed that at the beginning. I heard that. I read that. I read the treaty for as much as I could stand to read it. It was like, ugh, boring, horrible, like reading an insurance document or something. But you know, I heard about the berserker, you know, guy Jarl Andhoy, and how his ship was sunk and all that, and I repeated it, and I thought it was true. But now that I understand that this whole thing doesn't work with the 2 mile high ice wall right around the outside, and it's not needed under the concept that there is a free flow from east to west, like a Mobius strip, like a Klein bottle, like other some of the amazing fourth dimensional type stuff. I mean, it's amazing how people will push back against the concept of a portal, but yet they believe in black holes they've never seen before. They believe in you know, the what's that belt, the radiation belt, the Van Allen belts. They believe that. They don't. I've never been there. You ever been there? I don't know that that's even there. I don't know that that's even real. But people, well, they talk about that Van Allen belts like they talk about clothes in their closet, like it's an everyday thing. So that's part of trying to learn to face reality here. You know, if there's some kind of a seamless method of something moving from east to west in perpetuity, I mean, if you just keep going around and around and around, I would think you're just there's only one way to keep going around and around, and it is, and since the AE map doesn't work, we have to fill that in with some other concept of how that happens. How do you go from east to west seamlessly? Unless there's either portals, gates, some dimension crossing that you don't see. You know, I'm trying to keep my mind open as to how that can work. But I watched a video the other day that someone sent me about the Mobius strip, and I invite any of you to go on YouTube and look up videos about flat Earth, and use the term flat Earth and Mobius strip, and you'll find some of these videos that absolutely explain how this seamless thing can work. I mean, I watched one guy to make a Mobius strip out of a sort of a wide piece of cardboard about this wide, and he, you know, did the 1/2 twist and he taped it together. Okay, and then he took a pair of scissors and he made a clip in it and he started cutting it in half. And he kept turning and he was cutting it in half and cutting it in half, and got to the other end and he cut it in half, and then he had two Mobius strips connected together. Okay, and you're like, I can't even wrap my mind around that without having watched it. But now that I watched it, now I understand the concept, and that's something real and tangible and simple that we can all see. So if it can happen in that way, then why can't it happen on a bigger scale, a much bigger scale? I'm not closing my mind to that. And anybody who makes fun of portals and there's a bunch of jokers talking about pac-man, you know, pac-man portals and so on and so forth. Well, I don't know how it works, but I'm saying, and you're saying, we're saying that there is some phenomenon that goes with this mapping system.
Yeah, because as soon as you disprove the AE map, and I think we've done that fairly conclusively now on several fronts, and then when you look at flights, you know, that fly from one side, you know, to the extremities and re-emerge on the other, which they do on flight radar as well as time and day, they're just mirroring reality. So there are portals or pac-man gates, whatever you want to call them. These things are there. There is no other explanation for it. You know, there's no other way, because there is no edge. There is no physical edge that stops, you know, that there is no dome to stop things going. You just move and seamlessly move back to the other. And you could prove it if you went on a cruise. That would be the easy. If I had the money to do it, I'd go and book myself on a cruise. I'd have my maps and I'd be up on the deck every couple of hours and taking some map readings and seeing which direction the ship's going. And I would take my map behind me with me, and I would take an AE map and prove that one wrong. And somebody somewhere will probably do that before too long.